verifying zeros of polynomial functions. We're going to go from possible to actual. So we're going to narrow it down from a list of possible zeros to find the real ones that actually work. Not real like real numbers, but actual zeros of the function. I'm picking up one of the problems from the last video. We found these potential zeros. I tend to say potential, books tend to say possible. These are the numbers that could end up being zeros. And I want you to think about what we mean when we say zeros. When we say zeros, we mean x-intercepts. When we mean x-intercepts, we want an x value where when we plug it in, we get a y value of 0, or that the function is equal to 0 when we plug in this value. So what we're going to do is we're going to try all these different numbers using synthetic substitution. We could use direct if we wanted to, but synthetic's just easier in my opinion. So we're going to do synthetic substitution. And we're just going to pick any of the numbers. I just start with 1 usually because it's easiest. So write more words there if you need to. We're going to do synthetic substitution, picking any of the numbers. I just work my way from the smallest to the biggest. I start with the integers. If I run out of integers, I start doing fractions. Do synthetic substitution, and what we're looking for is a 0 at the end. We're looking for the fact that if we plug in this value of x, that the function is going to be equal to 0. Or if you like thinking about it as a y, that my y would be 0. So I'm just going to start with 1 because it's the easiest. So this is that one. Remember, we just bring it straight down. 1 times 1 is 1. We get 10, 10, 33, 33, 48. Nope, that doesn't work. So it's not going to be 1. So we're going to move on to another try. We're going to try -1 just because it's the next easiest number in my opinion. This guy comes down here. 1 times -1, not -9, -1. And that gives us 8, -8. 23 minus 8 is 15. 15 times -1 is -15. There's our 0. That's what we want. So the more you can tie this together with what it actually means, the less this is just memorizing magical steps. Remember that what this thing down here means is 1x squared plus 8x plus 15. And if you can factor that, there's no need to continue trying more substitution. If you factor it, you're done. So I know that all of my zeros, because it's x to the third, we expect up to 3 zeros. We know that -1 is 1, we know that -3 is 1, and we know that -5 is 1. I could have kept doing synthetic substitution. If I'm not great at factoring, sure, but you need to be able to factor it. When this coefficient here is 1, you need to be able to factor those that quickly. So here is the graph. It's the shape we expected. We expected that snaky shape going up to the right, down to the left with a third degree. We have up to 3 zeros. In this case, we have 3 zeros, -5, -3, -1, just like we found. Y-intercept is +15. That's the constant. So this is exactly what we expected it to look like. We should be able to get that in our mind with all the information we have. Here we've got the other example that we came up with the possible zeros for on the last video. And we're just going to start our synthetic substitution. I'm going to start by trying 1 into 2, 3, -11, -6, 2, 2, 5, 5, -6. Be really careful. Some people are going to say that's 0. It is not. So that doesn't work. Let's move on to -1. 2, 3, -11, -6. 2, negative 2, 1, negative 1, negative 12, 12, nope. Next, let's try 2. 2, 3, negative 11, negative 6, 2, 4, 7, 14, 3, 6, which means 0, so that means this is one of our zeros. Now at this point, I have options. I could, what do I know? At this point, I know that 2 is 1 0, and I know that there's possibly 2 more. I know that this is one of the factors. Basically, I know that x minus 2 times that whole big thing gives me what I started with. So I could factor, or I could keep doing synthetic substitution. I hope you're very good at factoring. So let's try factoring. Things that multiply and give me positive 6 and add up to positive 7. All right, it's going to be 1 and 6. Nice and easy, both positive, everything's positive. 2x squared, positive 3, positive x, positive 6x, positive 3x, 2x, positive 1. So x plus 3 times 2x plus 1. The solution to this one is negative 1/2. The solution to this one is negative 3. So those are my other two zeros. So my complete list of zeros, my answer is negative 1/2, negative 3, and positive 2. I'm going to actually erase some of this to make myself some room. I don't often do that, but I want to leave some of this stuff on the screen. If I had kept going and I kept doing my synthetic substitution, I could have done synthetic substitution on this littler thing, and I really would have to try 2 again, because, so again, we already have the answer. I'm just showing you this would have been the other route to go. I didn't have to go back to the big whole original one because I already know that I've already narrowed down what we're working with. And I don't have to try things that wouldn't be a possible factor of this one. So I don't have to try 6 anymore, because 6 would not be one of these factors, but all the rest would. So I have to try 2 again, because sometimes things will go in multiple times. You know and I know that it's not going to work because we've already know what the answers are. I'm going to jump straight to negative 3, but I wanted that opportunity to show you. You would have to try that same one again, because you can have a 0 repeat itself. So because I know the answer, I'm going to cut to the chase here. Because what I want to show you is, if you didn't factor it, if you did this, what would this answer mean? Right? You'd know that this was one of your answers. This was 2x squared plus 7x plus 3. So we're always going to step down 1 in degree. So this would be 2x plus 1, so you would know your other 0 is 1/2. So that's the alternate way you could have gotten those the second and third 0. Another cubic with a positive leading coefficient, so that's the shape we expect. Our zeros are -3, -1/2, and 2. I may do a couple more examples on a separate video, but I think that's enough to show you what to do. I may not.